The topic in this video is red-black trees. I am going to explain the properties of red-black trees and how to insert and how to generate a red-black tree. These are the two things we will learn in this video. Properties and creation of red-black tree. So let us look at the properties. See, first of all, red-black tree is a height balanced binary search tree. So it's a binary search tree. You have already studied about binary search tree. There is a topic available. And also we have studied about AVL trees that are height balanced binary search tree. So this is also height balanced binary search tree. If you remember, in AVL tree, we will try to balance the height by performing rotations if any balance factor is violated. Similar thing we do here, we perform rotations if red-black conditions are violated. So it's more similar to AVL tree. But this idea of red-black tree originates from 2, 3, 4 trees. So we already have a topic called 2, 3, 4 trees. If you are perfect in that one, if you have practiced that one, then this is nothing. Red-black tree is very, very simple if you have the clear idea of 2, 3, 4 trees. And even I am going to relate it with red-black tree with 2, 3, 4 tree in the coming video. Now let us look at other property. Every node is either red or black. So nodes will have color that are red or black. Some people take edges as color or nodes as color. So we'll follow nodes as color. Nodes are either red or black. That's why it is called as red-black tree. Then root of a tree is always black. So root of a tree is always black. So here you can see I have taken an example of red-black tree. This root is black. So root of a tree, that is the main node, the first node, is always black. Then nulls are also taken as black. See here, after this node, this is a leaf node. So this doesn't have any child. So but null are there. So if you know the linked representation of a binary tree, if you take a node will have a key value, and if it is a leaf node, then these values will be null. These pointers will be null. So those nulls are also treated as black. So I am highlighting them as black here. So nulls are also black. Now next thing, number of blacks on the paths from root to leaf are same. Let us count black nodes. 1, 2, 3. These are 3. 1, 2, and go along this path. 3. 1, 2, 3. Let us go in this direction. 1, 2, and this is 3. 1, 2, and this is 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So in every path you go, you should have same number of black nodes. That's the another property. Then no two consecutive red nodes should be there, right? Like this is red and this is also red, it should not be there. Like this is red, then this should not be red. So no two consecutive reds. It means if there is any red node, then its parent will also be black and the child will also be black, definitely. So for any node, parent and child of red are black. Then next, newly inserted node. When you are inserting a new node, always it is inserted as a red node. Then next and the last thing is the height of a red-black tree is minimum log n, maximum double of log n, that is 2 log n. So if you remember the height of a binary tree, minimum it can be log n, maximum it can be n. But when you are trying to make it height balance in AVL tree, it is 1.44 into log n. 1.44 into log n. Now red-black tree is 2 into log n. So it is little relaxing compared to AVL tree. So we can say that AVL tree is more strict, but red-black tree is not that much strict. So it allows the height to grow up to 2 into log n. So the maximum height of red-black tree is 2 log n. By looking at all these properties, you may be worried how to remember this. Do I have to remember all these? If you're writing academic exam, then you have to remember these, right? And if you're facing interview also, they may ask questions randomly from these properties. But do you have to remember these always? No, you don't have to remember them. If you remember the tree creation process that I'm going to show you next, that will help you recall all these points, right? So you don't have to spend special time in memorizing them. If you know how to create, you can remember them. So let us take few keys and create a red black tree. So I'll show you the insertion process, which is more similar to a BST, that is binary search tree, plus AVL tree, that is height balance, because rotations are also there. Let us look at tree creation.